Let me show you what we will be talking today. I think that there's a lot of there has been a lot of tutorials and hugs talking about simulating trees, and I've seen a lot. I've talked to Michael Goldfarb from SideFX last week about simulating that kind of effect. And at least in my opinion, I think there has been a gap because it's hard to simulate the tiny branches of the trees. And I tried what I think is somewhat new approach. So I've rigged the entire tree. That's what we see in the right. Even the tiny branches. This tree is, it comes from a speed tree. It's medium resolution. There are others with higher resolutions I'll show you. And my system will work on them, but will take time. I'll walk you through the entire process. So, well, that's it that we see today. First, let me at least introduce myself. I'm a Brazilian. My name is Guilherme. I have a small 3D effects studio here in São Paulo. It's called HardcoreFX, and I have a bunch of junior artists helping me usually. And and I am a mathematician. I've been working with Houdini for at least, I think, 10 years, 10 or more years. I think it's 12 years now. So, well, let me walk you through at least the steps of the system. Since I teach, I have a Houdini course in Brazil. I'm not a huge fan of tutorials because I think they don't take you on where you need to really use as a production. Usually, not all tutorials, but usually when you need something specific, and search, and perhaps you find a tutorial and you see that it doesn't take you to the spot you need to really show your clients and your client will like and so on. So my idea here is not to do a tutorial, but to discuss the pros and cons of this kind of system. I don't think it's one-stop solution, but I think it can work for a lot of situations. As you can see here, I don't think, just so you can find a common language, I don't think it works very well for the first part of the growing tree. But probably here I would use some blend shapes for this to work better. But for simulation, the branches and the movement of the wind, or perhaps a storm, it will work very well. And since the speed tree, I'll talk more about the speed tree model. But since the branches are they are not combined, they are separate pieces. We could use this for like chopping the branches in a storm or something like that. So with that in mind, I will walk you through the system. But first, if you have any questions, don't leave that to the final part, please. Just open your mic or send a message to the chat. Don't be shy. You can open your cam, just call me and I will stop the presentation, because I think it's better if we all go understand each step together. It will be easier for you to follow. So don't be shy. Just ask. All right. So here's the tree. I'm using this is Houdini. Sorry about that. This is the higher resolution tree. It takes some seconds to load. But I'm using the tools from KineFX to load the tree. Well, this one is taking more time than I wanted, but at least I have a lot of Houdini is open, so if one crashes, I can rapidly switch. So at first glance, when I was talking, this is for a project, this is for an actual project. At first glance, when I talked to my client, and he wanted to make a forest growing, just like the Noah movie. And I told him to send me models from SpeedTree, because their models, they come already somewhat rigged, as you can see here. Yeah, let me see. No, not here. Oh, I'm not seeing the. Perhaps this one that my client exported, it didn't come with the rig, but I think I have one with the rig. Just a minute. I think that's this one. And so the SpeedTree model, it comes with somewhat of a rig. Let me see. Yeah, I think that's the one. Here we can see it because it comes with an alpha attribute. Just took it off. And let me see here. Yeah, let me just rotate this tree so it's better. So here it is. As you can see, we have this rig, but it's very simple. Of course, we could subdivide somewhat these bones or splines, but it doesn't follow the branches faithfully, as you can see here. So I use that as a starting point, but as you can see, the tiny branches, they don't have a rig, and therefore the simulation for this will be handled by the main branch, and you have a more rigid motion. Wouldn't be so smooth or so vivid as it could be. So I'll come back to this layer. As I said, just let me walk you through the entire process. Then I come back and I take a further look into each step. So the first step is using the entire model without the rig. I don't know, I just use this FBX character import, but actually I'm not using any attributes that comes with it. So here I'm building the skeleton. As you can see, the skeleton I'm creating is for each branch. I have higher resolution tree here. This one is very heavy, as you can see. Let me see, 2000, 2000, I'm sorry, my dog is needing here. 2002 million polygons, and this one is like 10 times less. So if we switch here, as you can see, it takes more time, and this one is not the most expensive step. But as you can see, even the tiny branches will be rigged. So what that means, even the tiny branches will move independently. So we can simulate in my opinion, at least, how can I say that? Oh, a better simulation and more, as I said, vivid simulation, because you have even the tiny branches moving independently. As you can see here, we have 31,000 polygons. Each polygon would be like a bone in a rig. And the first one, just 1,000 polygons. So the other one is 30 times more. Just creating the branches is not enough, because since when you create a rig, you create a hierarchy of bones or joints. So this step, I'm creating just the curves, and the next step is to find a way to create this hierarchy in such a way that KineFX can work with it. So that was not an easy task. As you can see, it takes a bit of time. It's a for loop with feedback. As I said, I'll walk you through in some minutes. I have more loops than the number of branches, because some branches are not joined with the main branches on the first pass. So I usually put a little more steps, so I'm sure that will work. I have an attribute here to make sure is called to do. So there are no more branches to join in the hierarchy. So zero branches to do. So here we have a skeleton. This is not enough for KineFX to work, because KineFX is not just about curves. The first point is hierarchy. You can't have, let me draw here. Oh, where are my controls? Just 1 minute. I think I don't have controls for, yeah, I don't, perhaps this side effects link. I can't draw on the screen, I think. Yeah, I will perhaps use Illustrator here to show what I mean. I'll come back to this in a minute. So I have a rig doctor. This is the guy that will go to start our rig. So after this guy, we have a KineFX rig that we can work with. So this is our base rig. As I said, it's not just about curves, but we have a lot of transforms. So that's attributes that the KineFX suit needs to work. And well, this is the first part of the rig. Here, as I said, we have a rig. As I have seen in some presentations, people usually use this with a full body IK that you can shake the tree. That's cool, but when I put that in a Vellum simulation and I try to take the animation back to KineFX, it doesn't work. So that is why I said in the beginning that the tutorials usually takes us in half the path, but usually there are tiny things, tiny bits of knowledge that makes the difference to really reach the level of quality we want in a production environment. So in talking about animation, I'm using, well, as I said, I will take a further look in a bit, but I'm using chops. That's what is taking time here to make the branches grow. Is a mixture of chops to animate an attribute and this rig attribute VOP to here to create the transform. Since I'm a mathematician, I'm more or less used with working with transforms. It's not so fancy what I'm doing here, but I know for a lot of people, matrix is scarce. So, but we'll take a look in a bit. So here we have, as I said, the main, or at least the base animation. After that, I'm using Vellum to animate let's say the halfway through growing step. That's because I thought that working, or at least in my experience, working with Vellum in this kind of scale would be very hard. So I made a blend here to blend between just the regular joint animation with the simulated tree. So as you can see here, we have a bit more movement. Is not, I think, over there yet because I didn't have so much time to go into this simulation. I just got it to work last week. My main problem was making the system work. So, well, this is the rig part. The last part for the rig is just this blend between as I said, the animation from the joints, the base animation, and the animation from the simulation. So that's the rig part. But when I reached this point, I thought, well, I got it to work. It's working. It's well, I can use that for the presentation. I can use that for the project. So that's it. And that was when I started to do the capture part. And the capture part, the part was a bit of a nightmare because it was taking ages to capture. Usually, what would we do? Would be something like, well, let me show you in context. How will you see this? So what's the usual workflow for capturing? Let me quit here. Would be like using these bone capture lines. It creates this attribute, bone capture, that we don't have here. And it does some resampling of the curves. Here we can't really see it because it's already well spaced, but here I'm changing. I've changed this, but in the default, as you can see, this is not the default. Now here you can see that it does some resampling. And after that, we would do is use this stat embed. I think it's better than the other node. I think it's that conform or something. I don't remember. As you can see, it takes a bit of time, but it's not so expensive. The problem is here. This guy, I still have to talk to the guys from SideFX to see if they can do something, perhaps post on the forums. Since we have a lot of joints, like 1,000 joints, this guy here takes ages to finish. And well, if I had to make the system for a lot of trees, that would be a huge problem, because I have a really tiny studio. I don't have the time to wait for this guy to compute. It's single threaded, so well, my machine has a lot of cores, but you see that's like 4% of CPU usage, and you wait and wait and wait, and that takes ages. So what I've done is, well, I will walk through, as I said several times in a bit, but it's a for loop that it reduces the number of joints for each branch for the skin capture. So since there are just a handful of joints for the capture process, it's like far faster than this overall approach. So here, as you can see, we have the capture tree. Here is like a small step to capture the leaves. It's not perfect. I'm just finding the closest branch, the closest position on a branch, and I'm taking the capture weight from there. So that's what's happening here. And then it will work with the bone transform. Here I'm just doing a soft transform just to help the grain effect. The grain effect, as I said, is not perfect for the grain part. I know that. Probably I would fix this. This is coming from this step. Probably the nearest branch is not the right one. So I think, well, probably I would just take out this by hand. So it's easier and are not so many. For the project I'm working, it will be shoot on a drone cam, so it's very far from the trees. So probably we wouldn't see these tiny problems. So well, that's it. That's the overall system. And now before I'm going into take a closer look at each step, I must talk with you guys, if you want, why this approach. That's a big question. because I see a lot of people just going and throwing everything in a Vellum simulation. And I can say that I tried it, and well, it will take a lot of time because the first time I tried this, I used this rig to control the main branches, and then my idea at least was using a Vellum sim to, oh, this has different attributes. Using a Vellum sim to simulate these tiny branches. The problem is they are very tiny. They have a lot of geometry, so it's hard to keep the shape. It's hard to keep the volume. We have here some intersections. Of course, we can, or we could do some Boolean operations to fix that. But overall, if we use a Vellum sim on just the small branches in this tree, it will take like several hours for it to compute. For me, at least, since I don't have a farm to just throw that in a farm, I'll have to wait in my computer. I have two computers, but anyway, one of them would be stuck on the simulation. And since it takes like, I think it would be something like 2 to 3 hours for this simulation. And I think it's hard for you to do some kind of artistic, to drive the simulation on artistic view if it takes like 3 hours, because well, you change the wind a bit, 3 hours. You change the weight or the stiffness, 3 hours. Well, it take ages. And this simulation here is taken, I think, for 110 frames is I think is 15 minutes perhaps. So it's we can have a lot of iterations. So we can like put our artist heads and use that more if we have more iterations in a day than in a simulation that takes 2 or 3 hours. So that's why I am not using Vellum, at least for the the main geometry, and I'm using Vellum hair for the KineFX rig. That's why I've chosen this approach over the Vellum approach. And as I said, just simulating this, we wouldn't have so many movement in the tree as we have when we simulate this. So it's a huge difference. So, well, now I think I can go and walk you through and take a closer look at each step. But before that, do you anyone have question about this? Do you want to ask something? Let me see in the chat. No one? Don't be shy, guys. You can ask. Oh yeah, sure. Mark, is that right, Mark? Yes, I will talk. I will talk about how I did that, because there are, as I said, tiny problems that they actually are big problems, because, as I said, for me, when I got into this step, I was like very happy. I thought I wouldn't or I couldn't reach this with this tree. And when I reached this step, I was very happy, And then I tried to use that for a rig, and that was when I knew, well, it will take a lot of steps to really make it to work. And at this stage, I didn't know if I could reach the point that I actually did. So, well, first, let me show you how I did. That's not so difficult. I've made some assumptions. I don't know if it will work with trees other than speed tree, and I show why. Probably it will, but I'm not sure. First assumption: all the branches are separated. As we can see here, we have connectivity. Let me show you here. Yeah. As you can see, each different color is a different branch. They are all separated, as I said. Yeah, here. As you can see, they are separated. The speed tree it comes with the caps for each branch, but I removed it, and I'll show you why. But as you can see, they came with the cap. So here we have just the branches without their caps. And here I'm using a for loop for each branch. And the second assumption is the start of the branch is thicker than the end. Why is that? I'm using that. Oh, I'll find it. Let me see here. We have a branch. Here I'm using polyfill to create the caps. And the idea here is to me find here where I've changed this so many times, but the idea is I find the area here. I'm using a measure to find the area of each cap. So probably that's is my assumption. Oh, where's the normal here? Probably the start of the branch will have a larger area than the end. So that was the idea. And here I'm using that. And here I'm using the area to sort the primitives. So the idea is that this, since it has the largest area, it will come first or come before the end. So let me see here. The idea here is as this. I'm using this loop to use a group expand. Let me see. Oh yeah, here. I'm using this loop here with group expand to find the other loops. So for each loop, I will create a point in their centroid. So with these centroids, we can make a line. So the first one is for the first loop, the second, the third, and so forth. Here, the group expand, it creates this, let me see, it creates this step attribute here. So the first would be step 0, the second step 1, and so on. So here I'm using this attribute for another for loop. And for each step, it will create a point in the middle. So that's why we really need this kind of topology with these loops. If we don't have loops, like if this tree was passed through a remesh or some kind of workflow like that, this wouldn't work. And then I'm using that to create a line. Here I'm just getting the idea of the branch, and it's done. For those that are not don't know how to work with the invoke compiled block, for me it's very handy. It is just running the same bunch of nodes for this guy here. Actually, right now I don't need to run two separated loops. I could use just one for the entire tree, as you can see here. It will work. So I like this. This was for one of my tests, but I left it there. The parenting part was another difficult part. The solution I came up was a bit slow. That's what we can see here. 2000 loops. For the other tree would be like something about 40,000 loops. So it's it will take far more time, like 20 times more. The straight skeleton from the labs, as far as I can see, as far as I know, it just works on flat shapes. I've tried to flatten the branches, but since some of them goes on a sloper, right, angle, it doesn't work so well. So we can see it here. Labs. Oh, this I think Labs is not installed on the beta, but the Labs tool, it uses this Polyspan 2D, and the Polyspan 2D just work on a flat geometry. So that's why. Well, I've tested it, and at least I couldn't find a way to make it work. So that's why I'm using that. Michael Goldfarb, I must say, he used a vex function from the KineFX library to make this. Well, I can't say effortlessly, but the tree that he got from Speed Tree had some kind of path attribute. And the path attribute he got was like a hierarchy. So this, let's say, this first bone, let's say, would be the root of the hierarchy, and this one would be parent to that, and so on and so forth. But for this rig, so at least this FBX that my client sent me, it didn't have the path attribute as I saw Michael in his video. So even if I use the same approach as Michael, it wouldn't work because it just worked for this rig and not this one, because this I would have to find a way to make this path attribute with a hierarchy, and that's what I'm doing here in a way. So well, I don't think, as I said, the workflow Michael used would work for this, and straight skeleton wouldn't work too. So what I'm doing here? Oh, as I said, I made the assumption that the root of the branch is thicker than the tip. So using that, I found a way to order the points. Here, the points are ordered, as you can see, from the root to the tip. So here, it will calculate again. Let me cancel. So let me see here. I don't know where, but I have an attribute to, let me see. Oh, here. Yeah. Since each branch is separated, I've used this enumerate to, for each branch, create this index attribute that goes from 0 to the last point in the branch. So the first point, or the root point, hopefully would be the points with index 0 for each branch. So I use that to find, in a for loop, the root point for each branch, and then join with the nearest branch. It's a little more difficult than that, but I think for now we can here use that kind of idea. So let me show you one of the iterations. As you can see here, we have the root point. It will be joined together with the nearest point. It's not so simple because my idea was try to find the next tip, or at least exclude the nearest point if it is another root. Let me show an example here. For this guy, it will find like this point, this point, this point, this point, this point in here. It is a PC find, so it will search for the nearest points. And my idea was, well, exclude the nearest roots and trying to join with the other point that was left. So that was the idea, and hopefully that would work. And in the end, that worked. Let me increase the number of iterations. Oh, as you can see, So before and after. For KineFX, we have to fuse the points. It can't be separated because it uses some sort of neighbor search to find the hierarchy. So they have to be fused. That's why I have a fuse node here. And that's the idea for this. I've tried to use this stop condition. Actually, it was my first time using that to sort of make the for loop like a while loop. It didn't work as I expected, but because my idea was keep looping until all the roots are connected, but it didn't walk off the loop before the end. So I think I probably have to dig a little more in the help to see the usage of this, because right now I didn't see anyone using that. But that's the idea for the joints. If this works, the rig doctor will work. If here, let me show you something here in Illustrator. No, probably it's due to Zoom because it's a little slow. But let's see, we have a branch here, another one here, and another one here. If, like, let's say this branch somehow connects back here, this will break the rig. So we can't have loops in the rig. It can have a start, but the end of the bones or joints have to be free. So it was it took a bit of time for me to find all the problems and find a solution that really worked in all situations. Hopefully, it will work for other trees, but this can't happen. The rig doctor will give you a warning if you have like closed loops. The other thing is this orange join. It is from the 19, not from the 18.5. It creates orientations for each joint. It will help next on the line on the next step. So all these steps just to have a rig. Here, well, I can go back here if you want, but there aren't so many things going on here. Just this rig attribute VOP with an attribute in the scale. I'm using the attribute in the scale here. In the scale, since no, let's come back here. With the orient joints working, when you have like a bone or two joints, this is the z-axis. I don't know the other where will be the other axis, but this one would be the z. So that's why I'm scaling on the s, the z. And well, this is the animation in the rig. And then the problems, they don't stop there. I was using the Vellum hair. I'm using a thicker hair or spline for uh, the main branch, because it will help to make the tree stay, right? So it doesn't fall. I've I've tried with the string, but the string doesn't. Well, even with the highest stiffness, stretch and bend stiffness, it's hard to make all the branches to be at least stiff. Usually they all fall down, and I had to choose pin or glue to make them stay. And well, the result was not so good. So that's why I started trying Vellum hair. But the problem is the Vellum hair. I think we can see here. The Vellum hair creates this rest vector attribute. Probably it's a quaternion because it's a vector 4. And this is the orientation of the branches. And when I put here the Vellum sim here to use this Vellum rest blend to make it grow. The idea was simple. Do a rest blend, the rest length here, they are growing because the tree is growing, and the Vellum solver will or would update that, and that would work. But the problem was, since the Vellum hair was changing this rest vector at each frame, the simulation goes nuts, and you can make the tree to stay well rigid. It starts to to go all over the place and stretch and scratch. Well, was a nightmare. And at the end, I understood that was the orientation was the problem, because as you can see here, we have 12,000 points in the rig, but after the Vellum hair constraint, it separates the points for each branch, for its bone, or for its curve, and it creates more points. So I couldn't use this as a target. As you can see here, I put a null to be the target, but it wouldn't work because the point count is different. So, all right. At first glance, I didn't notice this. And after I noticed, oh, all right, let's use the first input here as the target. All right. But since the Vellum hair constraint changed this this rest vector attribute at each frame, as I said, the simulation goes crazy. And well, how to fix that? Well, the Vellum constraint is clever enough to use orient attribute, since it's a quaternion too. So what I did, since this here, since this orient joints, let me show you. The rig daughter doesn't create the transforms, although we could do here. Yeah. I don't know if this orange joints is bad. I think it is. I don't know the logic behind the red dot. Of course, it could see here, but I don't see orange. Oh, yeah, it has here. So probably with this and this probably would be the same as using the two of them. So it is creating this X-form, is transform attribute, is a matrix. It's easy to transform this matrix into a quaternion. I've done it in VOPs with this matrix tree to quaternion. So it's very easy. And that does the job, because with that, this rest vector stays well, it doesn't change so much for each frame, and the simulation works. So that was one of the things that I learned during this long journey. Well, not so long. It was about a week, but and that is not the end of it, because the Vellum is not updating the transforms. The Vellum is updating the position of the points. The Vellum post process, it takes back the number of points, the same topology as we had, but I had to use these orient joints with the rest orientation in the second input. So it would update this transform attribute using the new point positions. That's important because if you don't do that, instead of your joints or bones be rotating, it would be like changing the offset, the translation offset. And here we would have the branches like stretching and squashing in this axis. So it's fairly ugly, the result. So we really need the orange joints. As I said, it's from the 19, so it's very good. And with this, we can use a skeleton blend, because without that, we can't blend the skeleton because the transforms, they don't match. So with this, basically, this got us back in the KineFX world. So for me, well, as I said, this step was important, and this one so we could take the formed positions from the points into rotation transforms. That is what KineFX need. So that's for the skeleton part. I think the only part that I missed was the skin capture. Let me change here to manual, because it takes time here. Yeah. What I'm using here is very simple. In the second input, I'm using the rig. In the first input, each branch, because here I'm creating this branch ID attributes for each branch, as I showed you. And here since the skeleton does have the same attribute here, the branch ID, here I find the spline, the curve with the same ID, and this one from the loop, grow the selection by one step, kill the others, and now we have far less joints to operate on the bone capture by harmonic. So it's far faster. Let me see how much time it will take. Well, as you can see, it takes a bit of time. Probably, I think, 10 minutes or so. So without this, it would take hours, probably. And, well, this one is not single-threaded, perhaps, but as you can see, it's not multi-threaded. And this guy and this guy, they can't be compiled. So if we could use a compiled block, that would help, but both of these guys can't be compiled, so that would work. I tried. And here, just as I said, it's fairly simple. I'm just using the near point function to find the nearest point here on the branches and get their skin weight to use in the leaves. And then with this bone capture attribute, we can use the bone transform in the leaves too. Well, so that's it. So, questions? Do you want to ask something? Let me see the chat. Anyone? Marek, did I answer your question with this explanation? Right, are there anyone still here? Yeah. Well, as I said, I thought it wouldn't work. It worked. I still have to test the part joints for this one, but I think it will work. Probably this one will be very cool to simulate because there's a lot of geometry. So, and the leaves, they are bare too. So probably after render it would be, I think, very pretty. Yes, I think you can break the branches because they are already separated in the geometry. I didn't use a Boolean to like fuse them together. The problem here would be the skin capture, but I would have to think a bit, but I think the workflow would be the same as like taking an arm out of a character using the ragdoll, because in the ragdoll you change the geometry. Here probably we would need a second capture attribute without the other branches. Let me show you. Let's see, we have the main branch here and another one here. As I showed you, for capturing the skin weight for this one, I've used the bone or the spline that I've created for this branch, but I use this one, and probably this, and this one too. And what I would do is to take out this and this. So I would have just this spline for the capture. So if the spline was moved away from the tree, it would take take geometry out too. I can show you here in Houdini. I don't know if it works, but well, for this, oh, here I would have to split the point, and we have a crash. Oh, no. Yeah, well, probably I would have to split the point here, but I think with that approach, just have another capture weight and changing the capture weight or changing the geometry for one of more weights or more joints captured, and the other one with just one bone, one segment captured. You could take out the branch without effort. Probably the Ragdoll workflow for this simulation would work too, because since we have all the branches separated, it would be like an arm from a character. So a capsule for the the shape for the collision would work, I think. So yeah, I think the Ragdoll workflow would work very well for this. Yeah, yeah. Hopefully, it's better than connected adjacent points. But as I said, I had to make a lot of assumptions for it to work. I can share this file. Of course, I can share the trees, but I would take the regular one from the free one from Speed Tree from Michael Goldfarb's talk last week. I change it here, and I will send the file, right? Yeah, yeah. My first, well, while I was thinking about the how I would approach that, I thought using the old wire solver. There's a class from oh, I always forget the guy from one of the guys from FX PhD is one of the best Houdini teachers, I think. I forgot his name. The guy from the sound HDAs, I forgot his name. But he has a classroom in FX PhD, very, very, no, it's ancient, but he used this approach, used the rig from SpeedTree, and I think he uses the old wire solver because at the time was the option we had. But as I said, using this approach, I think is better because we have more room for freedom. Useful attributes, it comes with a bone capture, as I said, but for this rig, if you want to use this, yes, you can use with the bone capture attribute it comes from. But I think that's one of the most useful attributes. I don't know what my client did, but this one came like with packed geos, and this one came with regular geometry. But anyway, it comes separated by the type of geometry. Let's say there is here, as you can see, there are 5 packages. One is the main branch, the branches. The other ones are the caps. There are the leaves, and there is this one. It's called fonts. It's like a branch, but it's flat for texture. I think it comes just with this medium and low resolution trees. This one doesn't have this font geometry. Oh, this one. As you can see, it has just the branches, the caps, and the leaves. So, as I said, the useful attributes are just this bone capture, this name, because you can separate the leaves, and the UVs. They are useful. All right. Well, any more questions? So I think that's it. Since I've done this in the beta, it will be released in the SideFX YouTube, perhaps, our site, after the release of the 19. I will try to wrap up a file with this setup with the free speed tree model, and I will send you the SideFX guys so they can put in their site too. All right. So, Paola is telling that will be in the Worldwide Hug page on the site. So that's it, guys. Thanks you all for the patience, and I hope I somehow can help you with this kind of simulation. And if you come up with something more clever, please just share. And if you have any further questions, just reach me. Let me see where. You can find me. My name is hard. It's easy to find. Just look for Guilherme Casagrandi. My name will be the presentation. So just look for my page in Facebook or Instagram or Behance, and I will try to answer if I know the answer. All right. Just a disclaimer: I don't use my social media to post work related stuff. So if you are looking for that kind of stuff, just look for the page from my company, HardcoreFX, on Facebook or Instagram or Behance. All right. So that's it, guys. I'm tired of talking here, so I'll take a break. Have a nice evening, and that's it. See you next time.